non-homogeneous boundary conditions. And we have seen that there are 3 non-homogeneities, and based on that there are 3 subproblems, and we know that the subproblems can be solved if they are the EBC or PIC category. If the subproblems are not in the EBC or PIC, we have to find out whether they are NHE or NHB category. NHB also still can be split between the PI, EBC and PIC. And NHE, of course, we don't have this problem. We will have in the next class of the NHE, and in that case we will be solving the NHE problem with the finite Fourier transformation. So, I think all of you understood that part. We have finished the rest of the part. Okay. So, now what we will be doing, I will just pick up one of the interesting problems and we will see some of the things what we have discussed here that may not be valid. For example, I will take this type of domain, square domain. This is adiabatic. Dou t by dou y equals to 0. Dou t by dou y equals to 0. This is t equals to 1 and t equals to 0. Our equation is dou 2t dou x square plus dou 2t dou y square equals to 0. Okay. What one could expect the profile here? What one could expect the profile here? This is first in the physical rigid transfer problem. The hot wall, cold wall, adiabatic, adiabatic. Right? The hot wall, cold wall, adiabatic, adiabatic. Pure conduction problem. There is no acceleration. What is the differential equation here? Is a parabolic, elliptic, hyperbolic. Elliptic partial differential equation. There is no time dependence, steady state problem, and more than one dimension. So you can close your eyes and say that there is elliptic partial differential equation. And for this elliptic partial differential equation, we have this type of boundary condition. For example, if you have a slab, hot wall and cold wall, how the profile will be? Remember heat conduction, how the profile will be? Yes. Okay. How the profile will be here? This is, so now the thing is that here is adiabatic, adiabatic. So if I want to have the isotherms for this place, I want to have isotherms for this place. How to find the isotherms? Isotherms means the particular line of temperature is constant. How the isotherms will be here? How the isotherms will be here? This is a temperature profile. Isotherm means if you actually travel. What is isotherm? If you travel along this line, the temperature is constant, will not change. That is isotherm. There could be another isotherm. If you travel along this, the temperature will not change. So they are basically called as isotherms. So how the isotherms will be here? So how did it look like? How did it look like? You know, please, yeah, you are saying something. Yeah, it could be wrong, no problem. No? Excellent, very good. Why? Because along this, temperature is constant. Along this, temperature is constant. If you go a little bit further, along this, temperature will be changing, but the difference in temperature will be same because there is no gradient here. Okay? So this is the way the isotherms should be. Now when we have adiabatic wall, situation will be same because on adiabatic wall, how the isotherms will be? On the activity is adiabatic wall. How the isotherm will be along the adiabatic wall? Called fundamentals of heat transfer. Along the adiabatic wall, how the isotherms will be? How the isotherms will be? You are saying something, somebody is saying something, somebody is saying something like that. So many things happening. I can also do the same thing in the class, like this, and go back home. Okay, any day, no problem. Here only. Okay. Yes, adiabatic wall, what actually happens? Adiabatic wall, what's the condition for the, I have discussed, I think, adiabatic wall. What is the boundary condition for adiabatic wall? You have discussed already, right? Adiabatic wall. Adiabatic wall, what is the condition? I have discussed in the class. What is the heat flux in adiabatic wall? What is the heat flux in adiabatic wall? Is there any heat transfer in adiabatic wall? If I put insulation, will there heat will go? Yes or no? See the level of your situation. Okay, if the heat won't go, then what is the heat flux? How do you define heat flux on a particular wall? If I give a wall, how do you define heat flux? Just one hand please and give the answer, don't buzz. How the heat flux on a particular wall? N dot lambda. What is lambda? That's what. You don't even know how to pronounce the symbol. N dot. What is that? Grad T. This is the direction of a particular point, the normal direction. N dot grad T equals to 0. Okay. So, if this is the adiabatic wall, how the isotherm should be? N dot grad T equal to 0. That means what? For example, if this is the wall, if dou T by dou x equals to 0, right? This will give dou T because n bar will be Ex. Dou grad T means dou T dou x Ex bar plus dou T dou y Ey bar. If you take dot product, you will get dou T by dou x equals to 0. Okay? If dou T by dou x equals to 0, how the isotherm should be? How the isotherm should be? That means what? If the temperature is T1 and the temperature is T2, so dou T by dou x 0 means this T2 minus T1 is approximately 0, and if you divide by delta x and limit delta x tending to 0, it will be dou T by dou x equals to 0. This much steps I have not done in my life. There's so much of steps. Again, tomorrow you will forget. I am teaching only for the benefit of my iPad, so it will be recorded. I am not teaching for the benefit of you guys. Again, tomorrow you will forget. You will say lambda T, grad T, all kind of things you will say. Okay. So that's why dou T by dou x equals to 0. That means the isotherm should be actually will be crossing like this, right? Perpendicularly. So how the profile will be here? How the profile will be here? Isotherms for this case? Any guess? You view the profile here. Here the isotherms are like this. What are the isotherms here? The heat loss of problem. Top and bottom also adiabatic. Top and bottom also adiabatic. Top and bottom also adiabatic. That means you know that along this, that isotherms have to cut like this. Then what they will look like? What they will look like? Will they look like this? Huh? Like parabola? Like this kind of thing? Like this? Parabola only we are telling. Either this or this. Parabola is like this only. You are saying like this. Huh? No, I don't know. You are saying parabola. I am drawing all possible parabolas. You see my situation. You are telling parabolas, fine. I am drawing all possible parabolas. You tell me what you want to tell. I drew all the possible parabolas. So one more parabola is like this one. There are 4 kinds of parabolas. This. What will be the profile? Will it be a parabola? Some fundamental heat transfer problem. No mathematics here. Fundamental heat transfer problem. This type of question comes in the GATE exam. At least for GATE exam, tell me, because you know that I am doing coaching here. At least for the GATE, the people who I want to see. That's what I am saying that I don't see any promise for a person who can do very good GATE score. Because this kind of questions will be asked. I know that. What is the answer from your side? No answer, huh? What's the answer? What it could be? It will be a parabola. I just want to stand together. Why to talk? Yeah, you may be laughing at me. I also laugh at you. What I will do, I look at you 50 minutes and go back home. There is no point to teach you guys. What it could be, madam? It will be a parabola. Pardon? I am not able to understand your English. Your English is very difficult. Maybe I should take course in humanities department. I don't understand your English. My English is very simple. I don't understand complicated English because I never had any training for English. What is the guess? Okay, fine. So at least you gave some answer. It should be like this kind of thing, right? Okay. That means if you have this kind of thing, I will show you. It could be this kind of thing, means some will be touching like this, right? That means at this point there are two isotopes. Is it possible? This is already made in code. This is some other values. Okay. That means at this point there are two values of isotopes. Is it possible mathematically or physically? And also another possibility is, are they perpendicularly cutting here? No. That means the S1 is not possible at all. So their objective is, whatever the situation, isotopes will be like this. So if you say they will be like this, then some will be actually, okay, this may be a possibility, but some will be passing like this, and this is not possible because 2 points won't have the same temperature. Then what's the next possibility? What's the next possibility? I am just seeing the level of stupidity. I am sorry to say that. The answer is so simple. I am seeing the entire 60 classes, how they are struggling. 60 people. How the 60 people are struggling. And you have potential get crackers. Straight lines, yes. That's what I don't know. Maybe it is his guess, but it's nothing but straight line. Vertical lines. These are vertical lines. That's all, like the same thing. I gave the answer. And why? These are all adiabatic ones. So along this there is no gradient. Because adiabatic, along this the gradient is there, and there is a conduction between transport, and that's what it is. And okay, now the thing is that how to prove it mathematically? This is the answer from physics. This is the answer from physics. And why this visible sense? Because when it is long in this direction, it is called semi-infinite approximation. Semi-infinite approximation. That means what? If one length scale is very big compared to other length scale, along that length scale, things will not change with that length scale. And in that case, that length is called as infinite, and the entire approximation is called as semi-infinite approximation. And for the semi-infinite approximation, along this there is no gradient. That's why this will be straight line. Same thing along this. This is also finite. But the thing is that this adiabatic, there is no heat flux in this direction. Okay, and that's why this type of profile. The point is how to prove it mathematically and this is a very easy problem to solve. We can see only one non-homogeneity in the problem. What the kind of problem it is? What category? What category problem it is? EBC problem. So for the EBC problem, what actually happens? You write T equals to xx and yy. Okay, and what are the differential equations? What are the differential equations you get? If you do separation of variables, what will you get? If you do separation of variables will lead to, I want to differentiate them separately because 1 by x and all those things is all gone. You should be directly able to tell me. You have done so much in last few classes. You should be able to tell me directly. You should be able to tell me directly. Yes? You should be able to tell me directly. What is the x direction equation and y direction? What is the eigenvalue? What's direction? Which direction? Which direction eigenvalue will be? X or y? Y direction. 15. Okay. And what actually happens? the equation then? Y direction equation? What's the y direction equation then? d2 capital Y by dy square lambda square capital Y equals to 0. And what are the boundary conditions for this? Without boundary conditions, you cannot find the eigenvalues by an eigenfunction. You cannot find the eigenfunction. You cannot find the eigenfunction. You cannot find the eigenfunction. What is that? While boundary condition is simply struggling, I don't know what level it is. I have done so much of the class. I'm really surprised. You guys don't not even, I don't know, everybody is actually having some other business. I don't see any problems in the class. What are the boundary conditions for this problem? Dou t, why, how dou t will come? Is the equation of y, how we are telling dou t? That means we didn't ask anything on the separation of variables. D capital Y by dy equals to 0 at D capital Y dy equals to 0 at y equals to 1. What will you get finally? With this, what will you get finally? The eigenfunction is y equals to a cos. So you can actually write the eigenvalues like this. It is better to write yn a cos lambda n y, put sine, and bn cos lambda n y. Put the boundary condition. dyn by dy equal to 0. What is that? What are we getting 0 then? What are we getting 0 then? Ayn is 0. Huh? What is that? Ayn is 0 means what? Not an. Yeah. And an then simple derivative you cannot do. See my situation. An lambda n y cos. See the situation of pathetic situation in my class. Never happened in my life in IIT Madras. This much. Minus sine lambda n y. Am I correct? Yes or no? It is equal to 0 at y equals to 0. What actually happens? So y equals to 0 means this guy goes and this guy goes. We won't get anything from this equation. Y equals to 0, boss. Both the terms having multiplication, right? Y. Am I correct? So a into 0 plus b into 0 equal to 0. Then that means a and b could be anything. There is no uniqueness.
Lambda y will be there.
1%, yes. Is that okay? Is that okay? A and lambda equal to 0. Then what actually happens? A equals to 0 or lambda equal to 0? Lambda can be 0 or not? Let's see about dy even by dy at y equals to 1. At y equals to 1, what actually happens? So this is equals to 0 for y equals to 0, right? So this term is ruled out. Only this term was remaining. Now what actually happens? Again, these things actually an lambda n. This term is combined with 0. We have proved it. Plus, which is cos lambda n plus bn lambda n minus sin lambda n equals to 0. Am I correct? This term is going to 0 because n equal to 0 and lambda equal to 0, or it is finding A in lambda n equal to 0. Am I correct? And then what actually happens then? Lambda n equals to 0. So there are so much of questions here. Okay, there are so much of questions here. If you see that you cannot have concrete situation. If lambda n equals to 0, this equation doesn't make sense as well. Okay. The thing is that this is the condition where all our theories broke. That means this is the situation where these kind of things will not be valid, and this is only valid if lambda n equals to 0. This is the situation where, see, lambda n could be 0 also. Lambda n could be 0 also. If lambda n equal to 0, what is the solution for this? Yn equals to A Am I correct? Yes or no? Okay, in that case, what will be the action? d2 yn by dy is equal to 0. That means what? Yn equals to a n yn plus bn. Xn will be a cn xn plus dn. So then you can go back home and try to see that this is actually satisfied. These boundary conditions, because with this what actually happens that you may not satisfy the boundary condition or you may not get the proper solution. First you try with this one, you have to justify why this will not give the solution. Okay? If not, then you have to have only one weapon, then lambda could be 0. And this is one of the unique cases where lambda equal to 0, and the solution is here. I can give the solution, which is nothing but cx plus d or something. So you can say f1x plus f2 is equals to t. This will be your solution. So try to prove that part and get the solution. So this is one of the unique cases. Very simple problem, but we can see that non-negative or non-zero eigenvalue will not give the solution. Only eigenvalue 0 is the solution. Next we will be going to the Basak equation. X square y double prime plus xy prime lambda square x square plus gamma square equals to y equals to 0. So this is the kind of problem it actually happens for the cylindrical coordinate system. Cylindrical fin type of problem. If you have a cylindrical fin in heat transport, this type of problem comes. So what actually we can do, if this type of situation is there, you can assume lambda x equals to s, so that we can have the simplified differential equation. And in that case, we can have dy by ds, which is dy dx ds, which is 1 by lambda dy dx. From here you can see ds is 1 by lambda, right? Dx is 1 by lambda. It's 1 by lambda dy dx. d2y by ds square will be what? We have done this kind of problem earlier for the nonlinear ODEs. d2y by ds square will be what? 1 by lambda square d2y by ds square. Okay. So now what we will do that we will change our independent variable from x to s. We will change the independent variable from x to s. So what actually will happen? In place of x we will write s square by lambda square y double prime will be what? It will be this d2y by ds square. We will write in terms of d2y by ds square, which is lambda square d2y by ds square in place of d2y by ds square, plus x means s by lambda, y prime is what? Lambda into dy ds plus s square minus gamma square y square equals to 0. Sorry, y equals to 0. And if you see that this getting cancelled, this getting cancelled, we are having s square d2y by ds square plus s dy ds plus s square minus gamma square y equal to 0. From your, we have got the table of the Bessel equation. I have given this kind of stuff already. From there, can you please tell us what is the solution for this type of differential equation? What is the solution of this type of differential equation? So, what I can do that, I can give this type of operator and ask you to find out the eigenvalues and eigenfunctions. In that case, eigenvalues, you can actually find out the eigenvalue auxiliary equation, and eigenfunction is nothing but the Bessel equation. Eigenfunctions are the Bessel functions. Eigenfunctions will be the Bessel functions. So, what is the general solution for this case? What will be the general solution? So, I get y as a function of s. Remember that, not x. Y is a function of x. S. I will get y as a function of s. I will get y as a function of s. I will get y as a function of s. If you look at your table, what you can see, generalized solution is given. You look at x square d2y by dx square is given there. X is replaced by s. Next term is x into a plus 2b to the power 2bx to the power y dab. What is the value of b and r if you compare? What is the value of b and r? B is 0, r is, doesn't matter, r, yeah, b is 0. Or you can actually have a 0, b half, and r equals to 0, 2s. And last term is s square minus gamma square y. That means d could be what? C will be what? C will be 0, d will be? S will be? Yes, and then we have found r is 0 already. Minus gamma square y. Remember that. That means c could be gamma square, right? Minus gamma square. C is minus gamma square. Okay, now find the general solution. Now find the general solution. Now find the general solution. What is general solution? Y equals to x to the power 1 minus a by 2, e to the power minus bx to the power r by r. Now we have found r equals to 0, right? What is the solution then? What's the multiplication term? Outside the bracket? Outside the bracket, what's the multiplication term? Outside the bracket, what's the multiplication term? My God, people cannot get anything. I'm really surprised. What we get that? X to the power minus a by 2 is x to the power 0, right? And next one will be again 0, so it is 1. Next is C1. What will be ZP then? Now look at the bullets. If root 2e by s is real and p is not 0 or integer, Zp denotes Jp and Z minus p denotes Zj minus p. Now verify whether root over d by s is real. Is it clear? Okay, what is p? What is p then? What is p then? What is s then? Small s. The small s is 1. Then what is then p? Root over gamma square by 1 by 4. What are you talking about? A is 0, no? Yeah, so then how do you become root over gamma square? 1 minus, okay. How much it is coming? A is actually coming as 1, right? If A is coming as 1, then how it is gamma square minus 1 by 2? Is that first term is 0, no? 1 minus 1 by 2 whole square. A equals to 1, right? Now, if A equals to 1, what is the square root term? What is that? Gamma, no? Yeah. Is that correct? Yeah. So what is P then? P is gamma. What is my root then? What is my solution then? Ys will be, what should I write? C1. C1. What should I write? What should I write then? My God. So much time I have to shout actually. What a level of the class. Nikita, what should I write? Nikita, look at me. What should I write? What's the first bullet says? What's the solution? Generalized solution is what? You only told. The outside the bracket things are 1. And generalized solution is then what? C1 Z3, the argument, plus C2 Z minus P argument. What is root P by S? What is S value? S value is 1. X. What is ZP replaced by? ZP replaced by 0. Huh? JP, not JP. J gamma. P already you got. No? See the thing. Then what's the answer then? C1. C1. C1 then what? C1 J gamma. What is that? X or S? Then C2 J minus gamma S. So S I replaced by lambda X. That's all. That's how we can find the solution. So simple. If you have this table, you can find this kind of things as solution. Okay, so let's look at a couple of problems on this. Okay, I will give another one. So I think we are quite comfortable with this table, right? This table you can actually do that. So this table you can carry in your end semester. This will be actually useful to find the solution of the Bessel function. So x square y double prime xy prime minus x square plus mu square y equals to 0 or gamma square. X square y double prime plus xy prime minus x square plus gamma square whole into y equals to 0. What will be the solution? What will be the solution? What will be the argument? Root over d by s x to the power s. What is root over d by s? Root over d by s is what? Root over d by s is 1, huh? Root over d by s. 0 somebody say, my God. If it is 0, how can you get the zp and z minus p? Root over d by s. Root over d by s. Root over d by s you are saying 1, huh? What is? That's what your arbitrary is saying 1. What is the sign of the d? This thing d. Yeah, so you are saying why you are saying plus 1. D is coming as minus 1. You cannot compare also the sign symbol because you guys don't care plus or minus. You are correct. You are correct. It is not real. You are correct. Mod is there, but it is What is actually happening there? See, point is actually it is if you look at the third bullet. If root over 2d by s is imaginary, when it is actually said root over d by s is imaginary, that is not mod. So that will give what function you get? You will get ip and I minus p, right? And the argument has to be real in that case. Got the point, right? Yes. Then go back to the argument. Then you go back to the argument. So that these 4 bullets will decide what will be the function. Your eigenfunction is jp j minus p, or it is y jn y minus n, or it is ip I minus p, or in I minus n. And also if you look at if p is 0 or integer, the third bullet is saying if p is not 0 or integer, here is p 0 or integer? For this case, so there could be the possibilities of the third and fourth bullet points. If third point is valid if p is not an integer, but fourth point will be valid if p is an integer. What is p then for this case? P is how much? P is gamma. P is how much you are getting? Okay, if gamma is real, in that case what actually happens? If gamma is an integer, then your function will be in and kn, right? If gamma is an integer, your function is in and kn. If gamma is, so there are two possibilities here. So you have to write properly, if gamma is an integer, your functions will be in and kn, or ip or kp. And the function is not an integer, it will be ip and I minus p. What is the argument now? What is the argument now? You have that in this sheet? White t-shirt. Okay, then why you are looking at me? I wanted the question. I am not doing the joker stuff here. What is that? What is the argument? It's a very simple problem. What's the argument here? Root over mod d by s. Mod d you already found 1. S is how much? 1. X to the power 1 is what? X. So your argument is x. Why it is taking so much of time, I don't know. It will be ip of x plus kp of x. So c1 ip of x plus c2 kp of x. I am assuming gamma is an integer. If gamma is not an integer, it will be c1 ip of x plus c2 I minus p of x. Correct? Next problem. Next problem is very tricky. Y double prime minus xy equals to 0. Y double prime minus xy equals to 0. How to solve it? Y double prime minus xy equals to 0. How to solve in terms of Bessel? How to convert this to in that kind of form? Multiply by x square. Huh? Am I correct? Multiply by x square. What will be then? X cube y equals to 0. Is that correct? In that case, what actually happens? Your a is 0. R will be something, right? S will be? S will be 3 by 2. Then what is your solution then? I want to have the solution. You tell me the final solution. Is there any term here now? Before the bracket? Before the bracket, any term will be there? What is that? Before the bracket, any term will be there? Before the bracket. X to the power half, yes. Root over of x. Before the bracket is root over of x. Next, C1. Next, C1. taking so much of time from your side. C1 J? J or I or K? What? J of what? J of? J, what is that? Subscript. J subscript. My God, simple thing I have to. J what? J of what? Some subscript has to be there. P. J of N. P. P is what? How much P? Don't say P. 3 by 2. What is 3 by 2? This kind of simple thing also you cannot do. J equals 1 by 3. Then argument. Argument is how much? It will be J or I or K or I don't know. Okay. What I will do that, I will put a question mark. I think I cannot do the kindergarten level of teaching here. I have to move to the next topic. I will not tell you the answer because you are not interested. Why should I tell the answer? You suffer. Okay, I will give another problem. Do U do T 1 by R do R R do U do R plus do Q by do Z square. This is what kind of problem? This is what? PPD. This is what PD? What PD? Parabolic. See, it is taking so much of time. I have asked 5 times to ask that to get the answer. Boundary condition. U R equals to capital R equals to 0. U Z equals to 0 to 0. And U Z equals to R into the R minus R. And initial condition is U T equals to 0 equals to 1. Okay? Dou U by dou T equals to 1 by R dou dou R of R dou U dou R plus dou T U by dou Z square. Boundary condition is, so if you can see that there are how many non-homogeneities here? 2 non-homogeneities. So you have to split up the 2 problems. How to solve it? You have to use the, what is that? Yeah, peak problem and EBC problem, and this could be the exam problem, and you have to give me the answer in the exam, not here. So this could be the exam problem. Next problem, one simple problem we are going to discuss here. Cylindrical coordinate system, d to u by d theta square plus lambda square u equals to 0. My domain is minus pi less than theta plus pi. U of pi equals to u of minus pi and u prime of pi equals to u prime of minus pi. What's the solution for this eigenvalue problem? This eigenvalue problem in cylindrical coordinate theta direction. This eigenvalue problem in cylindrical coordinate for theta direction. The question is, what are the eigenvalues and eigenfunction problems? Okay, I think I have discussed enough of the cylindrical. So cylindrical coordinate system is a high possibility to come in the exam. So please try to practice cylindrical coordinate system. Try to see how the eigenfunction equations will be, how to find the eigenvalues and eigenfunctions for the cylindrical coordinate system. Of course, I can tell you that Cartesian coordinate system are not going to give any problem. The end semester the questions will be coming from the cylindrical coordinate system. So before ending, I want to stress on the next part is non-homogeneous equation type, which is solved by finite Fourier transformation. which will be solved by finite Fourier transformation. What is finite Fourier transformation? Is very easy. Any function can be expressed as linear combination of basis function. So if you write u, which is summation ci phi I x1, I equals to 1 to. So this is the condition. So, and this phi I will be what? This phi I is nothing but the eigenfunctions. Okay? So eigenfunctions, as we have seen, if the operator is self-adjoint, what we can say? The eigenfunctions are what? Eigenfunctions are orthogonal. Eigenfunctions are orthogonal. So this will be the eigenfunctions. The operator is self-adjoint and the differential equation, most possibly cylindrical coordinate system, Cartesian coordinate system will get self-adjoint operators. In that case, the eigenfunctions are possible to obtain. You know how to find the eigenfunctions, you have the boundary conditions. Only thing is, if you know Ci, you get the solution. That means, if I ask you to solve grad square u equals to fxy, first time you are introducing this kind of equation, and we have not used it. We have not solved this kind of problem. That means I am asking you to solve rho to u by rho x square plus rho to u by rho y square equals to fxy. Okay? And what actually happens? The u, and we can see that both the directions, one of the directions we have the eigenfunction, and if that is for eigenfunction, it is possible to find out the Ci's, and if you find the Ci, you can get the solution. And we will show that if you know this technique, you won't be even going for the separation of variable. So finite Fourier transformation will be valid for any different part PD, either non-homogeneous or the homogeneous. But my experience says that once you learn the finite Fourier transformation, we won't be liking the separation of variables because this is so easy and the direct method. So that we are going to discuss in the next class. Thanks for guiding.